Alright, hi Jake. I'm going to help you find, you want to find the derivative of y is equal to negative secant to the negative 1 of e to the x. Sorry, I said that wrong. This is also known as arc secant, the inverse of secant of e to the x, but negative. So we're going to start by looking at secant of y is equal to e to the x. And these two statements are equivalent, actually, because if I just take the inverse secant of both sides, for example, the arc secant, the arc secant of secant just cancels, and then the arc secant of e to the x gives us, what we got right here. All right, so now that I have set that up, I'm going to start by taking the derivative with respect to x of both sides of this equation. So d dx of secant of y is equal to d dx of e to the x. Now, the derivative of e to the x, wow, that's a big line. The derivative of e to the x is just e to the x. And the derivative of secant is secant y tangent y. But then since y is a function of x, we have to use the chain rule and put a little y prime here. And what we're solving for here is that y prime. So I'm going to look at y prime being equal to e to the x over secant of y tangent of y. Now what we want to do is we want to get our functions in terms of y, these trig functions down here in terms of x. So to do that, let's look back up here at our original equation. I know that secant of y is equal to 1 over cosine of y. Now in general, the cosine of some angle theta is equal to the adjacent over the hypotenuse. That means that the secant of some angle theta is the hypotenuse over the adjacent. So if our top of the fraction, like we can write it like this, e to the x over 1, that means that if we have a right triangle, boom, I promise that's 90 degrees, we call this angle y, we know that the hypotenuse is e to the x, and we know that the adjacent is 1. Using the Pythagorean theorem, you can find that this side is e to the 2x minus 1, right? So now if we look back at our expression over here, we can see that e to the x is now going to be over the secant of y, which we just agreed by looking, here, do I have a highlighter? We looked right here. Oh, that's, okay. Well, anyway, we looked right here to see that the secant of y is equal to e to the x. So I'm going to put an e to the x right here. And then the tangent of y is going to be the opposite over the adjacent, which is going to be the square root of e to the 2x minus 1. So these cancel, and we get that y prime is 1 over the square root of e to the 2x minus 1. So now we know that the derivative of inverse secant, we can also rewrite it like this. The derivative of inverse secant of e to the x is equal to 1 over the square root of e to the 2x minus 1. So that means that the derivative of y being equal to secant x, secant inverse of x, of e to the x, is going to be equal to 1 over the square root of e to the 2x minus 1. There's a negative right there. And this is your final answer.